Hi, I am Baran and I will be presenting our work improving online line graph extraction by object lane clustering. Autonomous driving requires accurate online local scene understanding information. Thus, autonomous agents deploy object detection and online bird's-eye view lane graph extraction methods as a part of their perception stack. We propose an architecture and loss formulation to improve the accuracy of local lane graph estimates by using 3D object detection outputs. The method learns to assign the objects to center lines by considering the center lines as cluster centers and the objects as data points to be assigned a probability distribution over the cluster centers. Since our method uses the detection outputs rather than intermediate representations, a single model of our method can use any detection method at test time. In this work, we consider a lane graph as a directed graph where the vertices represent the center lines and edges represent the directed connectivity. Given a front-facing camera image and the semantic bounding box of object detections, our model estimates the centerline instances and which estimated centerline, if any, each object belongs to. Note that if an object is not in the traffic, for example, if it's parked, it is assigned to a background class or an artificial cluster. Let us represent the input image with I, the lane graph with X, and the object detections with B. Then we can define the membership indicator variable Z, which is essentially a probability distribution per object over the center lines. Now, what we want to do is extract the ground truth or label for this membership function. And in this work, we do this by a heuristic method where for an object, if its ground projection intersects with a center line, we assign that object to the closest center line. Then through Hungarian matching our estimate center lines with ground truth center lines, we can convert these labels to be in terms of our estimated center lines. You can see the whole algorithm here. Essentially, it includes the label extraction all the way to parameter optimization to maximize the total term mentioned before. The architecture is based on STSU, which is itself based on Jitter. The image is fed to a deep backbone CNN, and the objects are fed through an MLP to obtain the feature vectors. Then these feature vectors are jointly processed by transformer. For each object resulting vector, it estimates a probability distribution over the estimated center lines, which is essentially the Z membership function we talked about. Then we can create a loss over this and optimize the method to actually learn to cluster the objects around this estimated center lines. Here we show the results. Essentially, without going into too much detail, it can be seen that in both benchmark nuisance and Argoverse datasets, our approach significantly outperforms the state-of-the-art in all metrics. Here we show ablations. Essentially, we want to test the robustness of our method when trained with one object detection method and tested with another. And in table 3, you can see that the results are very similar and proves that our method is robust. In table 4, you can see the performance of our method in clustering the objects around the center lines. And again, you can see that there is very high accuracy even when it's trained and tested with different methods. In conclusion, we propose a model that utilizes the onboard object detection algorithms to improve the accuracy in lane graph estimation. The architecture is trained with a novel formulation that couples the objects and the center lines of the lane graph. We derive a clustering term that assigns the objects to the center lines, and this term is used as a loss to supervise the model. We report state of the results in Nuisance and Argoverse datasets, and our approach can successfully assign objects to the center lines. Moreover, we saw that our method is robust against use of different object detection methods in train and test times.